Hello, I'm John Ferreira, and today I'm presenting my life cycle assessment for a low-grade metal screw. I chose this product because it's widely used in construction, but its environmental impacts are often overlooked due to its small size. This is a low-grade zinc-plated carbon steel wood screw. It's about 50 millimeters long, 4 millimeters in diameter, and it weighs roughly 5 grams. The screw is made mostly of low-carbon steel with a thin zinc coating to prevent corrosion. It's commonly used in wood fastening for residential construction. For this life cycle assessment, the functional screw unit is one screw, weighing about 5 grams. These screws are usually sold in boxes of 100 to 1,000 with packaging made of cardboard or plastic. Using a single screw keeps the analysis consistent and simple. Life cycle overview. This slide shows the cradle to grave life cycle of the screw. It starts with raw material extraction, then it moves through manufacturing, packaging, transportation, use, and end of life. This linear diagram shows how materials and energy flow through each stage. And there can be changes depending on if the minerals are from a union town in Ontario. There's probably some strict environmental laws. But if it's a cheaper screw, say like made in China, obviously they have less environmental standards. So there's a range on, where's the energy coming from? Is it from, wind, solar? Is it from burning coal? Is it from natural gas? Is the packaging, is it plastic? Is it oil based? Is it cardboard that's been recycled? So there's a big range on the life cycle. So for our raw materials and manufacturing, the main raw materials are iron ore, coal, limestone, and zinc. Coal is used in steel production, and zinc provides corrosion resistance and protection. The main outputs, manufacturing outputs, carbon dioxide, air pollutants such as SO2 and NOx, and mining waste and wastewater. And I chose these pictures. These are actually the machines that make the screws, not the raw materials, but this goes in as a coil of steel to the bottom left, and this machine slides back and forth and it strikes the head of the screw. So really cool. It slides, strikes the head, puts like say the Phillips head in the screw, and then it cuts it, and then it ejects it out, and then depending on the size, operator loads it in a tray on this machine here on the right, and this machine slides back and forth here, and this is what rolls the threads onto the screw. So really cool to see this go on. So transportation and use. Screws are transported mainly by diesel trucks, but some are shipped, especially if they're imported from like say China. This generates CO2, nitrogen gas, and particulate matter. In a perfect world, if we could ship it in more efficient ways, like say trains or maybe, ships that maybe don't use heavy fuel oil. Maybe they're ships that use, diesel fuel. It's not super clean, but it's definitely better than, bunker C or these fuels that are not good. And, even trucks, in a perfect world, maybe you could use an electric truck to get it to Home Depot and not a, international, inline six diesel that is not, particularly efficient. So end of life. At the end of their life, screws can be reused, which is excellent. They can also be recycled or sent to landfill. Recycling is preferred because it reduces the need for new steel production. If landfilled, the screws corrode slowly over time, like over, thousands of years, so its environmental impacts are relatively low compared to other things. Environmental and public health implications. The main impacts come from production and transportation emissions. Like I said, CO2 emissions can contribute to climate change, and NOx can create smog rain. Particulate matter can affect air quality, and runoff can harm aquatic life. Like I think of the tannery that was in Oshawa. When there's no rules, industry just, if you're making screws in China, it's probably a lot worse for the earth than the ones that are made in Ontario. Pollution prevention measures. To reduce environmental impacts, using recycled steel in production definitely helps. Improving energy efficiency in manufacturing. So are we using energy sources that are renewable? Is our process new technology that's, doesn't produce, miles of tailing ponds that are, not nice to see. Reduce transportation distances. So, if in a perfect world, if we could make a screw in, Hamilton and ship it to Oshawa, that's not too far relatively. But making them in, provinces of China because they're cheaper and shipping them, 10,000 kilometers, that has to be considered, the cost versus the environmental impact. And encourage recycling. So screws are recyclable, which is excellent. These help lower the footprint. And, maybe if on the packaging we put something like this product was, made in a union factory with, good environmental standards, and, these things, just giving these things to the consumer, say that the raw material was, mined and manufactured in processes that are reasonable for the environment, and, maybe we're using recycled steel. Maybe the transportation is on clean trucks. If you marketed that to the consumer as a selling feature, that would probably definitely help that this process has been, someone's thought about it, and we're trying to do the best for the earth as possible. So our conclusion and references. In conclusion, a single screw has a small environmental impact, but mass production increases the overall footprint. Recycling is the most effective way to reduce emissions and resource use. So thank you, and I appreciate your time, and definitely, next time you buy something, even as simple as a screw, think about, what did this have an impact. So perfect, thank you, and have a great day.